Hi Rangers! In this video we're going to talk about graphing linear inequalities. So how do we graph a linear inequality? Well, we have 4 steps to help us. First, we're going to solve the inequality for y. That puts it in y equals mx plus b form. Once we have that form, we can go to step 2. We can graph it using the y-intercept and the slope. We've been practicing that for a few days. Third, we need to determine if your line is solid or dashed or dotted, same thing. And step 4, we need to determine if you shade above or below. And we have to make sure that the y is on the left side of the inequality sign. And then of course, we never want to forget about Hoy-Vux. That helps us with our horizontal and vertical lines. So starting off, we're going to talk about the types of lines. So we already said that there's 2 types of lines. They're either solid lines or dashed lines. So how we determine if it's a solid or dashed is based on the inequality symbol. If we have the inequality symbols with the or equal to's attached, so less than or equal to and greater than or equal to, when you graph your line will be a solid line. So it's going to look something like this. Okay, when your inequality is just less than or greater than, we're going to have a dashed line or dotted line. So what it's going to look like is something like this. Okay, then that's it for solid or dashed / dotted. Okay, then we need to determine how to shade. So to determine how to shade is based on how the inequality sign opens up towards the y. If it opens towards the y, meaning greater than or equal to, we're going to shade above. Okay, so you shade above the line, and I'll show you how to do that in our example. And if it opens away from the y, we're going to shade below. But you have to make sure you solve for y first. Okay, so we have to make sure we solve for y first. Because remember, there are times where we flip the inequality sign. Okay, so let's go to our example. And here's our reminder that we flip the inequality sign when you divide both sides by a negative number. Okay, so first things, we have to solve for y. We have to put it in y equals mx plus b form. Okay, so what this looks like, we have to move over this 2x term by doing the opposite. It is currently positive, so we subtract 2x from both sides. 2x minus 2x is 0. I'm left with a negative 3y is less than 12 minus 2x. Then I need to get the y by itself, so I'm going to divide everything by negative 3. Okay, and since I divided everything on both sides by a negative number, that means my inequality sign flips and opens up the other direction. Okay, so 12 divided by negative 3 is negative 4. And negative 2 divided by negative 3, 2 negatives make a positive. We leave it as a fraction for our directions. Okay, so you can leave it like this, or you can rearrange it as y is greater than 2/3 x minus 4. They are the same exact thing, we just rearranged the 2 terms. So based on this, we can determine that right here, our line is going to be dashed. And it's opening up towards the y, which means we're going to shade above. So now I'm going to use my slope and my y-intercept to graph. So I start by graphing negative 4 on the y-axis. Again, we always start on the y-axis. And my slope tells me to go up 2 and right 3. up 2 from -4, write 3, 1, 2, 3, and I have a new point. All you need is 2 points to graph a line. Now that I have that, I can go ahead and connect them with my dashed line. Okay, so I'm going to connect them with my dashed line. It's going to look like this. And we need to make sure that we fully extend it. Okay, just like that. And then we put our arrows on it because it's going to keep going. Now I'm going to switch over to my highlighter so we can shade. So we want to shade above. So how we determine that is we put our pencil on the y-intercept and we go up. That means that is the above. Anything below that, if we went down, that would be below. So we're going to shade all of this area right here. Okay, so now that we've done that, we can answer the following question. Which of the following points is in the solution set to the inequality? So we're given 4 different points and we want to know what is in the solution set. So solutions can only be in the shaded area or on a solid line. If it's on a dotted line, it falls through and it's not included. Okay, so it has to be in that top shaded area or on a solid line. So what we're going to do is we're going to plot all of these points to see which one falls in the solution area. So we have 3, -2, which is right here. Okay, that falls on our dashed line. Again, it's going to fall through the cracks and it's not going to work for us. So no, it is not in the solution set. 6, -4 would be over here. 1, 2, 3, 4. Okay, again, not in the shaded area. It is not a solution. We have -4, 1, which is over here. It is in this shaded area, so far so good. Let's go ahead and check D just to be sure. 2, -6. So 2, -6 is somewhere over here. Again, not in the shaded area. You could also use your calculator and plug each of these points in to our original equation, and it would tell you true or false. But C is the only one that falls in the shaded area. Again, it has to be in the shaded area or on a solid line. So A did not work because it was a dotted line. So moving on to our summary, to graph a linear inequality, my inequality must be solved for, yep, you said it, y. Then I can graph using my blank and blank. Well, what 2 things did we need to use to graph? We needed our slope and our y-intercept. And if my inequality sign uses less than or greater than, my line is, yes, it is a dashed line. And if it uses less than or equal to or greater than or equal to, my line is solid. Good job. If my inequality is solved for y, and it looks like y is greater than or equal to, I shade above. And if it looks like y is less than or equal to, I shade below. Okay, now a point is in the solution set if it falls in the shaded area or on a solid line. Okay, that's important to know. So what I would like you to do is, if you have any questions, go ahead and write them in the left-hand column, and be sure to ask your teacher and